Okay, in the last class, we have studied destructive tests. There are various methods like how to determine the mechanical property, hardness of metal or metallic material. And today we are going to focus on non-destructive tests for inspecting the defects in the material. Firstly, there are 5 elements for non-destructive tests. If you want to conduct a non-destructive test, there will be 5 elements. That means this is actually the basic principle of non-destructive tests, how the test can be conducted or how a new testing media can be developed. Uh, if you understand this, then you will be able to develop new testing techniques or modification of any techniques, so that to make it much easier for understanding the defects on the surface or subsurface in metal or alloys. First one is the source for non-destructive testing, which is called probing medium. There has to be a medium which, in the second one it says modification or change in the probing medium. Orthat, that means this probing medium has to change. There has to be a medium which has to be changed. For example, if we talk about the litmus test for acid or alkaline, in that case, what we do is that we use the litmus paper, which is a medium. When we dip it into the liquid, then we see that the medium changes its color. Okay, so the probing medium is the litmus paper, and the change in probing medium will be the color that changes. And detection of change, and we need to have a system which has the capability of detecting the changes in the medium. Yeah, in the case of example of litmus paper, the change is in color. If someone is color blind, then he will not be able to detect it. Or if you are using sensors to detect the colors, then that's okay. Okay, then you have to have some a system that can detect the change in the probing medium, and that is called detection. And the indication means the means of indicating the signal from the detector, whether the change occurred or not. It has to be indicated by something. Okay, and that's the indication of that is the realize. It's kind of a realization or displaying the result. Okay, uh, for example, the litmus paper has changed its color, then your eye has detected the changes, and then you say that the color is blue. Okay, and that is the indication. That means you have indicated that indicated the change in the probing medium. Okay, and the fifth one is the interpretation. And once you said the color is blue, litmus paper has color has been changed to blue, then what does it mean? What does it mean by blue? There should be the interpretation technique, like what does it mean by blue? Or if it is red, what does it mean by red? For example, if it is red, then you can say that it's an acid, and if it is blue, then you can say that it is alkaline. Then in that case, that is called the interpretation of the indication. When there is an indication, you need to have the you need to interpret the indication so that it bears the meaningful meaning. Okay, it has the meaningful indication. Okay, so do you have any questions so far in here?
No, sir.
Okay. So the commonly used non-destructive tests are here, like liquid penetration test, magnetic particle test, acid pickling test, ultrasonic test, radiographic test, and eddy current test. Among them, there are two different type of techniques actually. First one is for detecting detection of the surface defect, and the second one is for detection of internal defects. Okay. If there is internal defect on any material and you want to identify that this, in the surface there will be no defect, but internally there will be defect, in that case you need to use this 4 5 6 these techniques. And for the surface or subsurface defects, you have to use the liquid penetration and acid pickling. Basically the liquid penetration and acid pickling are the surface can only detect the surface defects, but magnetic particles sometimes can detect a little bit deeper than surface. Okay, that is why we say that the magnetic particle test can be done for detecting the surface or subsurface defects. Okay, we'll go through all of these actually today's lecture. The first one is the liquid penetration test. There is two types actually. One is dye penetration, or another one is fluorescent penetration. And in the case of dye penetrant test, we this is the method here. You identify the cracks on any surface like metals or ceramics or anything else using a penetrant and a developer. The penetrant is basically a wire-like material that is sprayed on the surface of the of the product that you are going to test, and the developer is sometimes powder or sometimes powder mixed with liquid. Okay, so how does it work? How the dye penetrant test work? First of all, you have a surface with a crack on it, but it will have a lot of dust on it, and also oils and greases, and there might be oxides of the metal. Okay, you need to really clean the surface very carefully so that there is no grease or foreign material exist on the surface. And after the cleaning, you put the penetrate on the surface. And penetrate, due to the high capillary action of the cracks, and the penetrate has also the great affinity to the crack, to the capillary action, and that is why this penetrant penetrates into the cracks. Okay, because of the capillary action, the penetrant actually flows into the crack, and once the penetrate is penetrated into the surface cracks, then the extra material, that means extra penetrant, has to be removed from the surface. Okay, once you clean all the extra material from the surface, you still won't be able to visualize the crack, where the location of the crack will not be visualized. Sometimes maybe for larger cracks you might be able to see it, but in some cases where the crack is very small or tiny, in that case you will not be able to see that where the crack is, uh, until you spray the developer on the surface. Okay, and for the once the surface is cleaned, then you put the developer on the surface. The function of the developer material, that means it can be powder or it can be powder with liquid. These are the commercial names of this kind of one of the developer D70, and another one is BP30. Okay, BP30 is the penetrant. So when you sprinkle the developer on the surface, then what happens is that this developer actually pulls out the penetrant inside the crack, and it is pulled out on the surface and sprayed. Once it comes out of the surface and is spread, then you will be able to visualize the cracks like this. Okay, you'll be able to see the cracks uh, where the crack is, and also how extent the crack has covered. Okay, the what length the crack length or crack size can also be sometimes determined using the dye penetrant test. Okay, do you have any question here?
স্যার ডাই কালার আর স্যার মেটাল কালার সেম হয়ে যায় তাহলে স্যার
Yes, that's really a nice question. If the color could be similar sometimes, and that is why there is different types of penetrant and developer are available, and the color of the penetrant and developer are contrasting color. For example, if you have a penetrant developer of white color, and then you need to have a penetrant of red color. Okay, in that case, the when you apply the developer on the surface, it is white, and then when the penetrant comes out, then it will show red. Okay, and that's how we distinguish it. There are a lot of variations in the colors, but mostly red is used because red does not actually red is contrasting with the metal too, right?
Yes, sir.
Okay, any other question?
No, sir.
All right, so uh, in the next one, the similar, actually the fluorescent penetrant test and the dye penetration test, penetrant test, both are same. The only difference here is that the penetrating liquid that we are using, that means penetrant that we are using, is will be of such property that emits visible light. Okay, of such material which emits light when it is exposed to ultraviolet radiation. When you look at the surface on the ultraviolet, using the ultraviolet radiation, then you will be able to see the cracks are shining. Okay, exactly like this under the black light. What is the black light? Black light is actually the ultraviolet light. Okay, when there are some kind of lamps that emits ultraviolet light, which is called black light. When you expose the material on the black light or ultraviolet radiation, then you will be able to see that see this kind of shiny structure on the cracks. If there is any crack and the penetrant liquid is stuck on that. Okay, and in that case, the procedure is similar to the previous one, like dye penetrant test. Everything is same. You use the penetrant, you use the developer to bring them out on the surface, and then you can then you hold it under the black light to see this, because the penetrant liquid is containing it's emitting the visible light, and which will be when you hold it under the black light, then you'll be able to see it like this. The application of this is that why do we need the fluorescent penetrant test? Because it will give you the better picture compared to the previous one. If you look at the previous one, this one, instead of these kind of messy things, and sometimes you won't be able to see some cracks. But in the case of mm, fluorescent particles, it emits light, and you will be able to visualize the crack much more efficiently, because you will be watching a black background with a shiny lines on the cracks. Okay, and that is the good thing about the fluorescent penetrant test. Any question?
No, sir.
Okay, the second one is the magnetic particle test. Okay, can anyone say in the first one, in this either say the fluorescent penetrant test, in this case we have actually studied in here, like we have five different elements, five basic elements for non-destructive testing, and we have already studied two of them, like liquid penetrant test, or two types, dye penetrant and fluorescent penetrant test. In this case, what is the probing medium here?
Sir, dye.
Dye is the probing medium. And then does it change?
No, sir.
Probing medium must change, right? Yes. This is a bit complicated in here. Okay, it's not like litmus test, litmus paper test. The paper color has changed, but in here, what happened is that using the developer, you bring out the penetrant on the surface, and then surface has changed, right? Before taking out the penetrant, you won't be able to see anything. You will be just see, you will see the plain surfaces. You will not be able to see the cracks. Okay, and what the because of using the developer, and penetrant has come out on the surface, and you'll be able to detect that change, don't you? That means it's not direct change, but indirectly something is changing, and that is the probing medium, the penetrant. And because of using developer, the penetrant is coming out. That is the change what happening in here. Okay, and the detection of the change, you already detected through your eyes in this case. Okay, and then you interpret that when there is penetrant coming out in there, then that actually indicates the crack on the surface, and then how you can interpret it, like how much crack, how long the crack is, how deep the crack is. Okay, these are the indication or detection and interpretation. Okay, okay, the second one is the magnetic particle test. This is applicable only for ferromagnetic materials which is attractive to magnet. There are four types. First one is the residual. In the case of residual test, um, in the case of residual test, the workpiece to be inspected is magnetized. Okay, and then first magnetized and then covered with fine magnetic particles or iron powder. When a workpiece is magnetized, then it creates the magnetic field lines. Okay, and when you sprinkle the iron powder on the surface of the magnetized specimen, you will be able to see the magnetic field lines, and the particles will be aligned with the magnetic field lines. Okay, and that's how you actually detect the let me see, actually detect if there is any crack. If there is any crack, then the magnetic field line will change, because once there is a crack, there is another north pole and south pole created, and when another north pole south pole created, then the magnetic field will change, and that change will be visualized in there. I'll show you with image. And the second one is the continuous. Continuous one is the magnetization and application of particles may occur simultaneously. That means you do the magnetization, and also at the same time you sprinkle the magnetic powders or magnetic particles or iron powders or iron particles on the surface, and at the same time you will be able to simultaneously you will be able to detect the cracks. That is the continuous test method. Wet test method actually includes the magnetic particles that are held in suspension of liquid. Okay, the particles are mixed with liquid and they are flashed over the workpiece, or workpiece may be immersed in the suspension, and then apply the magnetic field on the specimen. Then the magnetic particles will be aligned with the magnetic field that has been created on the surface. Okay, if there is crack, then field will be disturbed, and that disturbance will will indicate that there is a crack. And the dry method, actually the particles in the form of fine powder are dusted over the surface of the workpiece, and then you apply the uh, apply the magnetic field. This kind of similar, they are residual or uh, on the dry method, both kind of similar type of technique, but one is first and another is second. Okay, how does it work? When you if it is a continuous workpiece, okay, there is north pole and there is south pole, and the magnetic field lines will go like this. And when you sprinkle the magnetic particles over the surface, then they will be accumulated on the if there is a crack, they will be, because of the strong magnetic field in that location, the material particles will be accumulated on those places. Okay, and the particles on the surface will also align with the magnetic field line. If there is a disturbance, then particles will be stuck on in that region, more particles will be stuck in that region, and that will indicate the when you try to remove the particles, then these particles will not remove so easily. Okay, and that's what actually creates the difference or changes in the probing medium, which is magnetic particles, and that's how we detect where is the crack. But in the case of detection, uh, it is important which way you are actually applying the magnetic field. If there is a crack, like in the horizontal direction, longitudinal direction, then you need to apply the current along the longitudinal direction. Then the magnetic field will be created perpendicular to the direction of current. The current flow direction and the magnetic field direction will be perpendicular. So once the magnetic field is created perpendicular to the that means in this case it is circular. Okay, it is circular, but obviously perpendicular to the current flow. And using this magnetic field, which crack you can detect? The first one is interacting with the magnetic field. Okay, when you move the device or through the cylinder, and then the longitudinal crack will appear. You will be able to see this because the magnetic field lines will be disturbed by the crack in here. And also for the at 45-degree angle, this one will also disturb the magnetic field, and the particles will be stuck on this region. Okay, and in the case of irregular cracks, or sometimes may show, may not, if this is very small, then it may not show. That means the magnetic particles may not stack on this region, but this one will definitely show. Okay, and this one sorry the, in this one is also a similar situation, like irregular cracks may show or may not show, but this one will not show because the magnetic field is applied parallel to that crack. Okay, if the magnetic field is applied parallel to the crack, that crack will not be detected because there will not be any north pole or south pole created on that region, because it is not breaking the magnetic field line. Okay, magnetic field line will be continuous, and that is why this crack will not be visible. So the summary is that if you want to visualize the crack using the magnetic field or magnetic particle test, then you have to apply the magnetic field in such a way that it actually uh, uh, stays magnetic field line stays perpendicular to the crack that you are trying to detect. So the thing is that if you want to detect the cracks, you don't know actually which way the crack is. Okay, which angle the crack is appearing. So that is why if you are if you are inspecting the crack on the surface of a material, then you apply the magnetic field line in the various directions, so that you can actually detect the crack. Otherwise, if you just follow one single line, then you will not be able to, you will be missing a lot of cracks, because a lot of crack might appear on the other direction. Okay, then you need to be really careful in this case. Okay, do you have any question in here?
No, sir.
Sir,
Okay. For magnetic particle test, there are two for the cylindrical specimens. There might be two different types, like longitudinal field. That means the magnetic field will be longitudinal, and the current flow will be circular in here. Okay, current flow will be circular, and the magnetic field line will be in this way, and the vertical cracks will be detected. And if you want to detect the horizontal cracks, then you have to apply the electric current through the cylinder longitudinally, and the magnetic field will be created surrounding the on the surface, and then you will be able to detect the cracks on the surface. And the another thing is the how do you determine the subsurface cracks using the magnetic field? And when there is a crack immediate below the surface, then there will be some accumulation of the particles on the surface. But if it is too deep, if the crack is too inside the material, then the magnetic that is the limitation of the magnetic particle test, because you will not be able to detect that. It only detects the crack on the most efficiently, it detects the surface crack, but the subsurface cracks sometimes can be detected, but it has to be very close to the surface, then you will be able to identify that. And another thing that I was talking about, like you need to apply the magnetic field in various directions to find out the cracks. Actually, in this case, say for example, this one is using the fluorescent magnetic particle. If you use the fluorescent magnetic particle and then apply the magnetic field on the specimen, and then you visualize it under the black light or ultraviolet light, then you will be able to see the cracks like this. If the cracks are like this, then if you apply the magnetic field only in the horizontal direction, then you'll be able to detect the cracks on this one, this one, or this one. But if you apply the magnetic field on the vertically, then you'll be able to see the only horizontal cracks, but you will not be able to see the vertical cracks. Okay, and that is why if you want to examine without the what does it call, the fluorescent particles, without, if you want to test without the fluorescent particles, only iron powders, then using this kind of device which actually creates the magnetic field from here to here, here to here. Okay, one is north pole, one is south pole, and the magnetic field is created, and you just rotate in various direction. You hold this specimen in various direction and then sprinkle the powders, iron powders on the surface, and then you will be able to see the cracks where the iron powders actually accumulates. Okay, gets strongly accumulated on the surface, then you will be able to see that, identify that there is a crack. Okay, so this is the magnetic particle test. Do you have any question in here?
Yeah, sir.
Okay, next one is the acid pickling test. This is actually similar to the etching. When we talked about metallography, there was a step which is called etching. When you use the acid on the surface of the material, a polished surface, then the microstructure will be visible. If microstructure is visible using the acid pickling test, we can visualize the crack also. Okay, on the material surface, you just finish it up and then apply certain acid for certain material, and when you apply that material, then you will be able to visualize the cracks, and the crack will appear like this. Okay, the similar way the crack will appear like this. Okay, using the acid pickling test, you will not be able to you will be able to see that with your naked eye. Yeah. Okay, you don't have to use the microscope. If you use the microscope, then you will be able to see the microstructure. So you don't want to see the microstructure, you just want to see the surface defects. Okay, cracks. In that case, you don't have to use the microstructure. Okay, and there are various solutions for doing the acid pickling test. Okay, the fourth one is the ultrasonic test. That means using the sound wave, we can detect the cracks. Not only cracks, we can also detect the determine the thickness of material. Okay, sometimes in the quality control, in the case of quality control, to control the thickness of material, you can use the ultrasonic test. There are three methods actually: through transmission, pulse echo, and resonance. In the case of through transmission test, you'll have an emitter which actually emits the sound wave, and another one is the receiver which receives the sound wave, and change in the magnitude of sound wave will be occurring if there is any crack. Okay, and that change actually indicates there is a crack, and you can measure the cracks actually by measuring the amplitude of the sound wave that you are applying. For example, if there is no crack, still some of the sound wave will be reflected. Okay, you will not be able to get the same amount. That means if you have a magnitude of sound wave when it is incident on the surface of the material, will not be the same as the magnitude of the sound wave that is coming out of the material. Okay, and there will be very small change. That means a naught will be greater than a t. Okay, but that will be continuous for all for anywhere. Okay, and you will be able to see, you will be able to predetermine that how much magnitude is changing in here. And when you move it to if there is a crack, then that change will be very huge. Okay, when that change is very huge, in that case, uh, a magnitude of the sound wave will be changing drastically, and in that case a naught will be very greater than a t. Okay, because some of the incident sound waves will be reflecting from the crack surface. Okay, and that's how we determine if there is a crack on the surface, and how far and how much crack, how long the crack is, can also be detected, because the change in magnitude will start in here and it will end in here. That means that will indicate the length, and how much reflection has occurred, that will indicate that the crack, how deep the crack is. Okay, and that's how we determine the crack on the internal surface. And if you want to determine the thickness, then this will give you the thickness. Okay, a naught is the incident um, uh, magnitude of the sound wave, and at is uh, the magnitude of the sound wave that is coming out of the specimen. Okay, then the change will indicate the how long does it take to travel, and then you can measure the thickness of the material. And the pulse ecosystem, do you have any question in here, the through transmission system?
No, sir.
স্যার ট্রাকটা যদি ভার্টিক্যাল হয় তাহলে
If the crack is vertical, was that your question?
জি স্যার
Then you have to apply
জি স্যার
differently. Okay, if the crack is vertical, then you have to apply the ultrasound in other direction. Okay, the next one is the pulse ecosystem. In this case only you are using a device that act as a receiver as well as emitter. Okay, you emit the sound wave from here, and once it is reflected from the back of the surface, you detect it on the same device. That means emitter and receiver both are attached on the same device. When sound waves are emitted from here, then a certain portion will be reflected from the surface. Okay, and that one is here. That means that will indicate like this in the oscilloscope. Okay, and when that is here, and then when the sound wave is reflected from that surface, okay, and comes to here, and that actually indicates another one, another reflection. Okay, that means there will be two reflection. One is immediately when it is on the surface, and another one is here, and this is the EP. That means total time it has traveled, sound wave, the traveling time. It's coming out here and reflected here, and then comes again here, and that is detected in here. That means this is the total thickness of the surface, that in terms of time. And here, if there is a crack, then that signal will be reflected another way. Okay, that means one is initial one will be here, then it will come here and get reflected in here, then you will get another disturbance in here, and another one will come from the bottom. Okay, that will be here. That means some will be reflected from the crack, and that's how you detect the crack. That the distance in here will actually indicate the the distance at which the uh, crack is positioned, the position of the crack, and the final one will be the reflection from the bottom surface. Okay, any question?
স্যার যদি আমরা থিকনেসটা না জানি তাহলে আর যদি ক্র্যাক থাকে মধ্যে যদি ওখান থেকে ফিরে আসে তাহলে তো মনে করব যে এতটুকুই থিকনেস
No, yep, that will be misleading. That's why you have to take the reading in at least 2, 3, 4, 5 locations to get the actual result. Okay, there might be crack. Actually, it is a really good question. Okay, there might be crack. That is why we to increase the reliability, we always say like you need to do at least 3 tests. Okay, and do the average.
ওকে স্যার
All right.
ইয়েস স্যার
Okay, the fourth one is similar to the second one, but only difference is that instead of using the regular wave, we actually in this case actually the system is adjusted in such a way that the wave that is created in here is a resonant wave. Do you understand the resonant wave?
Yes, sir.
If the similar amplitude coincides with each other and then the interference occurs, and then you at some point they create the resonant which is a very higher magnitude than the regular waves, right?
Yes, sir.
Magnitude of the resonant wave is very higher than the regular waves that has been interferenced. So in that case actually we the resonant wavelength is used. If this wavelength is disturbed somehow, if there is a crack in some places, then the resonance will be disturbed, and when the resonance is disturbed, that will be detected in the system. That means the resonance has been disturbed, and that's how we detect the crack. Okay.
স্যার কোন জায়গায় ক্র্যাক আছে স্যার এটা বুঝবো কিভাবে স্যার মানে কোন জায়গায় পজিশনটা আছে স্যার ক্র্যাকের এটা বোঝার কি আছে আমরা
No.
করতেছি স্যার
In that case, we might not be able to detect the position of the crack. But in the pulse ecosystem, you'll be able to detect the position of the crack, and also in the case of the first one, you'll be able to detect the position. I don't know actually. I'm not pretty sure about this. This method is not widely used. Okay, resonance system, but if it is also used in the case of like the resonance wave, it actually depends on a lot of parameters. For example, the incident wave that you are using, and also the thickness of the material. If the thickness of the material is not uniform, then resonance will be broken, because sound is traveling through the metal. Okay, if the metal thickness is changed, then the resonance will also change. Okay, that will also affect the results. Okay, so that's why probably this method is not widely used. Instead the pulse ecosystem is most widely used one. Okay.
স্যার আগের গুলোতে স্যার যেমন ভার্টিক্যাল আমরা হরাইজন্টালি সাউন্ড পাঠাইছিলাম স্যার কোন ভাবে পাঠাবে বুঝবে কিভাবে ক্র্যাকটা কি হরাইজন্টাল আছে নাকি ভার্টিক্যাল আছে এটা স্যার আমরা আগে ডিটারমাইন করার কোনো অপশন আছে কি নাকি আমাদের মানে
actually nowadays actually there are 3D scanning system. Okay, the sound wave is given in the various direction to visualize the crack 3-dimensionally. So the technology actually has more advanced really well, and you will be able to see the crack virtually in the computer. When you put it in a region where magnetic resonance, these transducers, that means sound wave producing devices, are placed all around the surface, and then you apply the resonance, and then you apply the sound wave, and then you will be able to detect the changes and visualize it in the computer. So this is just basic things that I'm talking about. Okay, these are just basic things. How does it work? Okay, and it can be advanced in many different way. When the probing medium is changing, and that change you can visualize it like using a graph. Okay, or using an animation. Okay, there are many different ways to visualize that changes. and that's how you how much change is occurring. If you want, if you calibrate that, then you will be able to see the location and the direction of the crack. Okay. I mute karo.
Sorry, sir.
Okay, the number 5 is radiographic test. You have, I think most of you have already done the X-ray or gamma ray test. Did you do that? Anyone here who did not do the X-ray? That's unexpected. Anyway, the radiographic test actually detects the internal voids. In the case of, if you want to detect the internal voids or cracks, then you do the radiographic test. How does it show in the photographic film? It shows as the dark area. Okay, it actually shows as a dark area on the photographic film. Okay, if there is a flaw in here, then that will be detected like a black area on this region, and if there is a void, then it will show as a black region on the photographic film. Okay, and then the solid region will show will be brighter. Okay, and you will be able to measure the crack and also measure the thickness, location, and everything. Okay, very simple. Next one is the eddy current test for electrically conductive material. Eddy current test can only be done on the conductive material, otherwise it's not possible. What is eddy current? Eddy current is the secondary current because of the application of a primary magnetic field. When the alternating current is applied on a surface, that means current is flowing through a coil, and you bring the coil close to the surface of the material, and then there will be a primary magnetic field will create. Okay, will be created, and that primary magnetic field will induce another secondary magnetic field on the because of the induction principle of induction. The secondary magnetic field will be created on the specimen, that means on the metal, and because of that secondary magnetic field, there will be eddy current created on the surface, which will rotate in the perpendicular direction. Okay, that means that you apply the alternating current using a coil, and then you get a primary magnetic field, and that when the magnetic field is close to the surface, a secondary magnetic field will be created, and that secondary magnetic, because of that secondary magnetic field, there will be eddy current created on the surface. Okay, and somehow if that eddy current is disturbed, if the metal is continuous, there is no crack, then eddy current voltage will not change. But when you this system actually experience a crack on the surface, then eddy current voltage will be changing. Okay, and that when you detect that change, that indicates a crack is present on the surface. Okay, and how much extent the voltage, eddy current voltage changes will actually determine the thickness of the crack or length of the crack. Okay, and that can be calibrated. Any question here?
স্যার ভোল্টেজ তো প্লেটের সব জায়গায় ছড়ায় যায় স্যার, তাহলে কোথায় ক্র্যাক আছে বের করা যায় কিভাবে স্যার?
No, when there is in the induction method, when there is a change in the magnetic field, that can be detected indicated as voltage change. You measure the magnetic field, you don't measure the eddy current. Okay,
জি স্যার।
there is a magnetic change magnetic field measuring device which actually converts the changes into voltage, and I was actually talking about that voltage. Okay,
জি স্যার।
okay, the next one is the holographic test. In the case of holographic test, you actually create a interference pattern. Okay, and then you can using that interference pattern, you can sometimes create virtual images. Okay, that's how the holographic holography works. Okay, you create the interference pattern and use that pattern to create the virtual image. But the purpose of this holographic test is not to create the virtual image. Instead, you will be examining the photographic plate. If you examine the photographic plate, you will be able to see the interference pattern, and that will actually show if whether there is a crack or not. First, you need to understand that how holography works. The coherent light beam, that means very small wavelength, the light beam of very small wavelength is passed through a beam splitter, where a certain portion of the beam is used to illuminate the object, and another portion of the beam is reflected on a mirror and act as a reference beam, and that beam is incident on the photographic plate. And due to the illumination of the coherent light beam on the object will also emit the light. Okay, and that light that object beam will come and strike on the photographic plate. Because of this reference beam and the object beam interference on the photographic plate, there will be certain pattern created on the surface of the photographic plate, and that pattern actually, if you look at that pattern, then you will be able to see some vertical or horizontal lines in there. Okay, and if you want to see this image again, then you just, what you do is that you use a reconstruction beam of the same wavelength as the reference beam. Okay, you apply the reference beam in here, and you look at the photographic plate through in this way, and then you will be able to visualize the virtual image in there. Okay, that's how the holography works. Okay, and using this holography, we actually get a photographic plate which actually shows whether there is a crack. That photographic plate will look like this. Okay, and if there is a crack, then the interference pattern will be concentrated in those regions. Okay, it will not be continuous. Okay, if there is no crack, then it will be continuous interference on the surface. Okay, and the interference will be broken if there is a crack. And that's how you actually examine if there is a crack or not using the holographic test. Okay, any question?
স্যার holographic টেস্টটা স্যার আরেকবার একটু বললে ভালো হয়।
I think you understand the X-ray, how X-ray works. It actually creates a pattern on the photographic film, right?
জি স্যার।
Dark and more dark grayscale pattern, right? A very
Yes, sir.
black region. If there is a blank space, then it creates a very black region, and if there is a bone, then it actually changes based on the density. Okay, and in this case, what happens is that the plate property changes. Okay, initially the plate has a plain color, but when you put it in this region and you use the coherent light beam, that means very small wavelength light beam, a portion of the reference beam is constant. How much reference beam property of the reference beam will be constant. Okay, and that constant property will interact on the surface, and also the light that is coming from the object will also incident in there, and then these two beam actually interfere with each other. Okay, and that interference, a pattern, because of that interference, a pattern actually reacts on the interference of the lights. Okay, the photographic plate actually reacts with the interference of the light, and that's why a interference pattern is created on the surface. If there is no crack, then interference pattern will be like continuous. Okay, the continuous interference pattern will be there, and once there is a crack in some region, that interference pattern will be disturbed around the crack. Okay, if there is a crack, then pattern will be disturbed, pattern will be different. But in the case of holography, holography is different from holographic test. Okay, in the case of test, you use this photographic plate to visualize the crack, because the photographic plate will have this interference. And if you want to see it as a holography, then you use the magnitude or property of reference beam through this way, and you visualize it in this way, then you will be able to see the virtual image. And if you see the virtual image, you will not be able to detect any cracks on the virtual image. But if you look at the photographic film, then you will be able to detect if there is a crack or not. Okay, did you
স্যার
understand?
এখানে জি স্যার স্যার এখানে বিম স্প্লিন্টারটা স্যার কি করতেছে
Beam
কোহেরেন্ট লাইট
splitter
দিলে
is actually, the beam splitter is actually splitting the beam. A certain constant portion of the beam is reflected from here, that will be that will be predefined, and rest of the beam beam will be incident on the object, and that object will emit the light to keep it constant. Okay, there will be any there won't be any other light, only the splitted illumination beam will be incident on the object, and then object from the object there will be the object beam to keep the coherent light beam constant. That means the magnitude or wavelength of the beam will be constant throughout. Otherwise, if the illumination beam is different from you get the illumination beam from a different source, and that is not complying with the splitter, then you will not be able to visualize the object, and the interference pattern will be different. Okay,
জি স্যার বুঝতে পারছি
anyone else? All right, that's it for today. In the next class we'll study the crystal structure of the metals. We'll start with the crystal structure of the metals. Let's see how far we can go, and after that we'll go for phase what is that, phase diagram. Actually, we'll go to phase diagram, and then that will be much interesting, I hope.